Hello, we are Team 2013, the Gearheads. I'm Kyle.
And I'm Sia.
And welcome to our 6th Java training video. On today's agenda, we have exceptions, writing documentation, reading documentation, and if you have other people with you, a group programming project. First up, we've got exceptions. So, exceptions are a method of dealing with errors in code. And exceptions will stop the execution of the current method and then go back in the stack trace until the exception is handled. And if it isn't handled in the main method, then the Java virtual machine will deal with it. Basically, what the stack trace is, it's just a list of the methods that have been called to get here. So when a method is called, it'll just put down like a piece of paper with the current method, and then each time a method is called, it'll put down where execution go back to, and then when an exception is thrown, it will read the stack trace, so it'll know exactly what code was called to get to the current method. And then all exceptions are fully fledged objects, which means if you make your own exception, you can and should put information pertinent to what caused the exception into the exception object so that anyone handling your exception has more information to work with. There are multiple different types of exceptions. The first is runtime exceptions, which are generally for programming error. Some examples are null pointer exception, index out of bounds exception, and a lot more. In runtime exceptions, if a runtime exception is thrown, you do not need to check if it is thrown. You still may if you want to, but you do not have to. The next type is exceptions. They're thrown for adverse situations that you need to handle if something goes wrong. Some examples are IO exception, which is something going wrong with in and out, interrupted exception, which is a problem waiting for something to happen, and there's also a lot more that are not listed here. Exceptions with the exception type are checked, meaning that you must either handle the exception in your code if you're calling a method that can throw one of these, or force the caller of your method to handle the exception. How this is actually handled, we'll talk about in a bit. And then next up are errors. Errors are for something that you can't really handle. Some examples, the virtual machine error, which is the JVM is broken away and it can't continue operating, which you can't really handle. And then assertion error is something should be impossible, but it still happened, or something happened that shouldn't have happened. All types of errors should never be handled, and the only error you should ever throw is assertion error when you're saying, hey, this code should never get called, but just in case, here's an assertion error. Next up, we've got throwing exceptions. So you use the throw keyword and then an object of the exception type to throw an exception. So yeah, it must extend one of the exception classes, and then you need a semicolon afterwards. And then when an exception class is initialized, that is when Java will look at all of the methods that have been called to get here and keep track of that information so that it can be accessed at a later point. And if the main method doesn't handle the error, then it will print out all of the methods that were called to get to where it is. And if it has access to the line number, it will tell you the line number. Exceptions can also be caught. You use a try block, and then any code in a try block, if any of that code throws an exception, or if any of those methods or code throw an exception, then Java will search for a catch block that matches that exception. So, for example, here we have arithmetic exception. So this block would catch any arithmetic exception or any object that is a subclass of arithmetic exception. And then it would just print out division by 0. You can also put a finally block, which is optional. If you have a try block, you must either have a catch block, any number of catch blocks, or a finally block. You can't just have a try block. So finally block, regardless of if an exception is thrown, the finally block will get called. So if this code doesn't throw an exception, the finally block gets called. If this code throws an exception and is caught, the finally block gets called. If this exception throws an or if this code throws an exception and it's not handled, the finally block is still called. And the finally block is usually used for cleaning up after something that the JVM doesn't know about. A good example of this is files. If you just ignore a file object, then the operating system might still think that someone a process is using that file, thereby preventing another process from using it. So what you want to do is make sure that if something goes wrong, we close it. There's also, for cleaning up after stuff like files, there is actually an extra Java mechanism that works with that, which I'll go through in a little bit. So, exceptions, you can also optionally give them a cause. All exceptions, checked or unchecked, can have a cause passed to them, or most exception types do. Exception causes are useful when you want to throw an error that makes sense for context. A good example of this is if you're implementing a list. Let's say that a null pointer exception is thrown if you try to index an out-of-bounds position. That would throw in null pointer exception, but since you're indexing, you probably want to throw an index out-of-bounds exception. So what you want to do is catch the null pointer exception, and if it's thrown, throw an index out-of-bounds exception with the null pointer exception as a cause, so that when you're debugging, you can see exactly what code was caused while still having an exception type thrown that actually makes sense. Next up, we've got throws. So remember how I mentioned earlier how checked exceptions you need to either handle it or tell the caller to handle it? Throws is how you do that. If you put throws and then an exception type that is checked, then the caller will be forced to either deal with that exception or force their caller to deal with the exception. In this example, thread.sleep can throw interrupted exception, but this method doesn't handle it, and it just says throws interrupted exception, so that the code that calls this handles it. So you should always put as specific as an exception as possible. In this case, interrupted exception is thrown, so we put interrupted exception. We would not want to put exception or something like that, because that would make it so that the caller would have to catch exception, which is not good since you don't want to catch too many exceptions. It's just not great. And if you have multiple exception types, then you can comma separate them in throws. Try with. So this is the mechanism where you automatically clean up stuff. In this example, we create a scanner. I'm not going to actually talk about what a scanner is, but a scanner is a way that you can read from an input stream or text and parse it. So in this case, we create one from system.in, which is the standard input. So what we do here is it creates the scanner object, or try with, you put parentheses, and then you create any objects that implement the auto-closable interface. There's a lot of them. And then you can also put a semicolon and then another variable initialization of a type that implements auto-closable, and as many as you want, and then you do an end closing parentheses, and then in curly braces you have some code. What this will do is whether or not the code throws an exception, the auto-closable will get closed, and it will make sure that everything is dealt with. So if you have something that implements auto-closable, you should almost always put it in a try with statement.
Okay, so writing documentation in JavaDoc. So first of all, JavaDoc is basically a way to document your code, which is always good to make sure that people understand what's going on in your code and just like different parameters and different things that they'll need to use it. And there's different ways that JavaDoc is shown. It can either be a form of a web page, which we'll show a picture of later on, or it can be just while you're hovering over things in some good Java IDEs. So for example, in VS Code, Virtual Studio Code, or in IntelliJ, if you hover over something, then documentation of it will show up in the form of JavaDoc. And it also doesn't impact your runtime performance at all, which is great. Okay, so quickly, the syntax for JavaDoc, you're going to start it with your slash and two asterisks, like this, and you're going to end it with asterisk and another slash. And in between, for each line, you're going to use asterisks to show that this is still within that JavaDoc. And then inside that inside that comment, you're going to first write a description of your method, and then everything else will be either in HTML or we'll show something later for parameters and other stuff. So one thing to keep in mind is you can use this tag, the p tag, to create new paragraphs, and you don't actually have to close the tag like you do in HTML. So parameters. So you can use @param to specify what a specific parameter means. So you should have this for all of your parameters, unless something is like really self-explanatory. So for example, in this method, you have the parameter messages. So in your Java doc, under the description, you're going to put in @param, the parameter name, and then you're going to describe what the parameter means. And yeah, also parameter, these ones can be in multiple lines. And yep. And @return. So @return is basically tells you what the method returns. So this will only apply to methods, but it also goes after your description. It'll just say, oh, this method will return, for example, for this method, the objects converted into optional strings. Yeah, and if you want to see, for example, what JavaDoc will look like in web page form, it's something like this. And yeah. So you can actually use @c or @link to reference other documentation of like classes, methods, or public constants. So for classes, like over here, you just put the class name, and then for methods, you're gonna put your class name, your method, and then any parameters that go with it. And then for constants, you just put a class name and then the constant. So @link is for inline referencing, which means that you can write it within the description. While @c is after documentation, which will create a C also section, and then that will have all your different information on there. So @code is a way to format the content to be more code-like. For example, if you see here, this is like normal text, and then it becomes name. The name becomes like more like code, and then it goes back to normal text because you have @code and then name. And for any example code, you want to use your block code and your pre-tags to make it like stand out like this. And then, yep. And @throws and also @exception, they're basically identical, and they also go under the method description, like right under there. And it basically tells you what exceptions the method will throw and like when they are thrown, basically. So both checked and unchecked exceptions should be documented. An example here is use @thrown, and then you have your exception, and then if something happens, so whatever condition they are thrown under. Okay, so deprecation. So deprecated code basically means like old, outdated code that you shouldn't use anymore, or like the user shouldn't use, and that is only kept in for backwards compatibility. So to write deprecated code in JavaDoc, you're going to use @deprecated, and that goes after your description of your method or whatever, and it tells you why this thing is deprecated, for example, redundant, and then it tells you to use this instead, unless it's not applicable. And then in your actual code, you're going to put @deprecated with a capital D for Java to know that this code should not be used anymore, and that will make it create a warning whenever that code is someone tries to use that code. And you can also use it to say, oh, this code will be removed eventually, or how long it's been deprecated for. So some final notes. You don't actually have to worry about the order of the tags after your description. And also there are other tags that we haven't talked about, but if you want to know more about them, there's a link here, and we'll put it in the description as well for you.
Mm-hmm. Okay, next up, reading documentation. So the reason why you want to be able to read documentation is frequently updated when the public API changes. So when new methods are added, or methods are deprecated or removed, or all of that stuff. And the documentation is generally made by people who knows what the code is actually supposed to do. So good libraries are well documented, and sometimes they even have examples. And since the documentation is probably code reviewed, then it's a lot more trustworthy than like other sources, and it's most up to date. And we can show you. So this is the Java documentation. This is specifically the Java 11 documentation. Up here we have the search bar. On older Java documentations, this search bar isn't here, but on any newer Java documentation, it will be there. So because of the way the Java 11 docs are organized, we have the module thing. If you're looking for Java documentation, you probably want to click on java.base here. And then once we're here in java.base, we have a list of all of the packages that are in here. So this is all the standard Java stuff. So for example, we have java.util right here. We also have java.lang and stuff like that. So if we click on, let's say, java.util, and then we have a list of all the interfaces here. and then a list of all the classes, and then a list of all the enums, all the exceptions, and all the errors, and stuff like that. You can click on them. So let's say we want to look at collection. So have a lot of information. Have the generic argument information right here with some documentation, all the interfaces that this extends, all the known sub-interfaces, and all the known implementing classes. So yeah. And then there's all the documentation on the class itself. Specifically, this has a lot. And then you have a method summary, which can be filtered by instance methods, abstract methods, and default methods, or just all of them. And then there's the short description, which is here. This is just the first sentence of the description. You can click on any of these and it will go to the documentation. As you can see, here's the full documentation add method. You've got description, parameters, the returns, and what it might throw. There's also a lot of other stuff. For example, if we go to use, we can see everything that uses collection. This is a pretty long page. So yeah. You can also see a very nice tree. So you can see the hierarchy for java.util package. Or if we weren't in java.util package before, it'd just be the entirety of the Java standard library. So you can see down here, where is it? Collection. You can see iterable, collection, they're all list, queue, deck, set, sorted set, and navigable set. So yeah, and there's a whole list of interface hierarchy and just general class hierarchy. Stuff like that. There's also a page with everything that's deprecated. For example, if we go to here, you can see deprecated fields, because it's not just methods that can be deprecated, there can also be constants and fields and stuff like that. Go back to deprecated. There's a lot of deprecated Java ID. You can also see an index. This is every single thing in Java organized by in alphabetical order. For example, if we're looking for something that starts with W, you can click on W. Then this is everything that starts with W. Yeah. And there's also this help tab. This has some extra information about how the documentation is organized. For the programming project of the video, if you have someone to work with, find someone to work with. If you don't have someone to work with, that's fine. So this is split into two parts. So the first part is look through the documentation for java.util.stream.stream and java.lang.math. So specifically for stream, read through the java.util.stream package info for more information. So each person read through their own documentation, and then when you both are done, then you can continue on with the second part. If you're just by yourself, then just read through both of the documentations. And if you're with another person, then after you're done reading your documentation, teach the other person what you've learned. Pause the video for doing this. Gonna continue to the next part in a couple seconds. For the second part of the group programming project, you make a method that takes a stream of objects with the information of 2 integers and 1 double, and you return a collection where each object in the collection contains the result of operations on the input object. This needs to include the smaller integer, the larger integer, the integer with the larger absolute value, the one with the smaller absolute value, the length of the hypotenuse, so the 2 integers passed in are the lengths of the legs, and finally include the sine of the double divided by the cosine of the double. You are encouraged to look at the documentation if you don't remember everything. So pause the video to work on this, and then we'll continue on with the solution in a couple seconds. Okay, so this is a pretty big programming project. So let's start. So the input we need is 2 integers and a double. If we look at the instruction size, we take the stream of objects following information, 2 integers and 1 double. So we have values to get each integer and the double. Next, we need to return a collection with each object having these different things. So we actually need to represent the output since we're putting it in a collection. So I have a similar thing. You have the smallest, largest, smallest absolute value, largest absolute value, hypotenuse, and the tangent. So here we have the constructor. We have values for getting methods for getting each different field. Finally, the actual code to convert between them. So, first in here is the smallest. So the smallest is just map.min. Take an A and B and it will return the minimum. Next one is max, the largest. So do here. And then we do the same thing except putting in the absolute values of it, because the next are the smallest and the largest absolute values, as you can see here. And then for getting the length of the hypotenuse of two integers are passed, or the length of the legs, you can just use math.hypot and then put in the two integers and you'll get the correct answer out. And then finally it is sine of the double divided by the cosine of the double. Since sine over cosine is equal to tangent, you can just call math.tangent. It's also valid to say sine of the input divided by cosine of the input. Also, for the output, you could have done these in different order. Here, they were just done in the order that they were asked for in the question. You could have a slightly different input ordering or a slightly different output ordering, but either way, each input that you parse should look like this. And then in order to actually get a collection, we just take in the list of something that makes sense, the input, get a stream of it, for each of them, parse it. Here it's just an entire method for parsing it, and then we collect it to a list. Since a list is a collection, this will work out perfectly fine. And then you will have the solution. This is the end of the programming project video series for now. Thank you so much for watching, and if you have any questions about any of the content, feel free to contact our team outreach email and we can try it, or in the comments, and we'll try to respond and answer your questions and potentially make new videos if some questions repeatedly get asked. Thanks for watching, and hope you have a nice day.